Hello, hello.
Hola, ¿qué tal?
Voy a esperar a que se junten un poco porque el lío es, según yo ya le quité la configuración para que cuando entre no suene, o sea, que no esté el tin, tin, tin. Me dicen si funciona, que yo creo que no. Lo voy a seguir intentando.
Esperemos que sí.
Sí, porque es un
Doctor
poco molesto.
Oyoki.
¿Qué tal?
Ya vemos que están llegando los demás presentadores. Qué bueno que nos pudieron acompañar. Muchas gracias. Tenemos... No, sí, sí, sigue sonando, Bárbara.
Sí, ahorita lo voy a quitar. Bueno, voy a seguir.
No, no te preocupes. Pues...
Solo la idea no es, o sea, es como no admitir alumnos a media clase, ¿no? O sea, un ratito nada más, desde el principio y ya después a que llegan tarde, ¿no?
Sí, alguien comentó en Facebook que entró a la reunión, luego se salió o se le cayó la conexión y después ya no pudo entrar otra vez.
Sí.
Estaban bien, bien enojada una alumna de que el host no me dejó volver y yo...
Qué mal host.
Today, we will have a very interesting talk by Vestas. We will have 3 different speakers today. We'll have Dr. Oyoki, we'll have Sergio Hernandez, and we'll have Andres Aguilar. The talk for today is called Vestas Turbine Solutions and Technology. Let me tell you a little bit about the speakers we'll have. First of all, Dr. Oyoki. He did his PhD at Tec de Monterrey, also a master's degree therein. The topic of his dissertation was predictive power control of a doubly fed induction generator in a grid-connected wind energy conversion system. Ooh, I have Dr. Abel Rio saying she cannot hear me. Can everyone else hear me?
I can hear you well, clear and sound.
Okay, so it's just probably Dr. Abel Rio having this issue because I'm not mute. So yes, he did some research in predictive power control, which is key for us. And for his master's, he did commutation strategies of an indirect matrix converted in wind energy conversion systems using FPGA. So Dr. Oyoki has been for a little bit more of 2 years at Vestas, but prior to that, he worked for Siemens Gamesa and for Grupo Niveau, which is an as an electric expert consultant. So all in all, he's got over, I would say, 8 to 10 years experience around wind energy, conduction generation, and control. We also have Andres Gerardo, who all in all adds for over 12 years experience around with the wind energy sector. Most recently, he's been for a little bit more than 4 years in Vestas as a Blades lead LATAM. This is all Latin America. Prior to that, a couple of years as service planner, Latin America. Also service planner for over 3 years. So yeah, he's got about 8 years up until now in Vestas. But before that, he was a site manager for Clipa, which means he was in charge of a wind farm back in Oaxaca. Over 50 wind turbines were under his responsibility. Prior to that, he worked for CFE, Mexico, also looking at wind farms in La Venta, down south in Oaxaca. So that's about 12 years experience around the wind energy sector. Finally, we have also Licenciado Sergio Hernandez, who is Human Resources Head for Latin America, also for Vestas. And he's been there for a couple of years. Prior to that, he spent almost 2 years in Enel Green Power, which is also related to electricity generation and efficiency. And he adds for a few other positions in Unilever, Sherwin-Williams, and the tax consulting group. So these are the three presenters we'll have for today. The presentation, as I mentioned, is called Vestas Turbine Solutions and Technology, and with any further ado, I leave the floor to them.
Thank you, Carlos. I will use just this initial couple of minutes before my colleagues start with the presentation, just to thank everybody for the invitation for this event. I think it's a really important opportunity for Vestas and for us to be part of this talk today and to share some time with the future professionals in Mexico and all Latin America. I would like to say that from the previous experience, it's really important to have this approach with young people and try to share experiences and all the path that we have gone. Maybe will be not so much, but it's something, and we'll be glad to share this with you all today. So I think Carlos made a really good presentation about my colleagues Alejandro and Sergio, so I will not speak more about them too. I will just say that the goal for us in this presentation will be to talk about Vestas itself and to talk about the leadership that Vestas has shown in the wind industry business, and moreover in the energy business, offering a huge portfolio of solutions in regards of energy production. And of course, we'll talk today about the new platforms and the new turbines. Those are very exciting moments because even 6 days ago, a new platform was released in the market. So we'll talk a little bit about that today. Alejandro will share with us some information. So this is the future that we talk few years back. I would say maybe making some memory. I was speaking with Alejandro just a few days ago, but when we started in the business, what we're seeing today, it's what we imagined or we thought that it could happen 10 years ago, right? So future has come, and we're here, and of course, Vestas is looking forward to continue being part of this future evolution and for the energy business, of course, right? So I think I will leave just this this time to Alejandro, who will start with some technical information to share with all the audience. So please take notes, and we'll have some really good time at the end for questions and any other information that you're looking for. Okay.
Hello, everyone. Honestly, I'm new in this kind of platform, so I don't know if, as I'm speaking now, I'm on the main scenario, but I will share my screen to start on the presentation. Okay. Please confirm when you're looking at my screen.
I can see it.
I can see it. I can see it.
Okay.
Mhm.
I will then change to full screen now. Okay. You see the whole screen or the notes, or I don't know. I'm really I'm new on this.
I can see the notes on the next slide.
Mhm. Yeah.
Okay.
I think what you have to do is in PowerPoint,
Okay.
when you share, you choose which type of screen you want to, or which screen you're sharing. Or if you wish, you can send it to me and I'll just.
Yes. Okay. No problem. Should I just hide presenter view, maybe? Well, it is not so nice. Please help me. Can I send you the presentation, or should I?
Yes, of course. Yes, of course. You can send it. I'll give you my email, De Gonzalez.
Okay. Sorry for this. Yeah, I know. I can try this. I will take out my secondary monitor and try to use it as the main screen. You see it now?
Worked.
Yeah, it's better now.
Okay.
Yeah.
I'm in the field support solution team, so this is part of my job. Look for solutions, not for more problems here. Okay, so let's go on. Okay. I prefer to start with the front. Well, the first slide is more like a mix of what I'm doing in research and what we are trying to show you about what is Vestas doing in the actual market. Okay, I will start with the background and the trend, maybe for 2018, 2019, and what we expected back then. So from the technology installed in the worldwide. Okay. This is part of a paper already presented in a conference, and it will be used only as a background to show you some of the topologies used or installed in the wind turbines right now, and what we expect to install, or what was expected to be installed in the turbines, or in the next years. So we are now in the next year, and we will tell you what we are doing now. From year 2000, we have some turbines, some small turbines with the rotor diameter around 50 meters, 1 megawatt of active power. What we expect in the last year, in this year, or in the following years, to have around 170 meters of diameter and close to 6 megawatts active power. Okay, this is the evolution of the size of the wind turbine, and in terms of the actual power that this turbine or this machine can deliver to the grid. I don't know if you're familiar with this term, but there are wind turbines that install in the land, or inside the land, or in the sea. So we have the onshore and the offshore technology. It is a different. There is a main difference. We can have the same, more or less the same turbine installed onshore or offshore, but in this case, what we see in offshore, we see larger diameters in the turbines, and higher energy or high power in the turbines. Okay, please take a close look to this expected size of the turbine, because we will talk about what is Vestas installing right now, and where are we, Andres and I, giving support right now, because you may see some videos, you may see some, I will say, prototypes in the market or in the media, but we normally work with those turbines that are already installed in the wind farms. Okay, so what we are trying to say to you is the turbines that are expected to be installed in 2025 or 2030, we are right there, few years earlier in the real market. Also, you may notice that these wind turbines collect mechanical energy or kinetic energy from the wind and convert this energy into mechanical and electrical energy, finally electrical energy. And this wind turbine is connected to the grid. So we can have this energy in our homes or in the factories or wherever, right? In order to collect this energy and transform this mechanical energy into electrical energy, we can have conventional drives. What is that? A gearbox that change this low speed rotation into high speed rotation, and this high speed rotation goes into the generator. We control this the electrical energy in the generator, and then extract the electrical energy from this generator. So we have conventional drive that is part of the drive found in the W-fed induction generator, also found in squirrel cage induction generator. We have some of them in permanent magnet, and we have this hybrid drive, which is a medium speed gearbox. And some of them in the other manufacturers have this direct drive, which is they don't have this gearbox. They work in low speed or lower speed as fast as the rotor can rotate. And we have several other transmissions which are out of scope right now, but you can see here that Vestas is number one in conventional drive and in hybrid drive. Okay. This is maybe quite technical here for someone which is who is not electrical. But what I want to tell you here is that depending on the generator topology, we have the converter topology in order to control the energy extracted from the generator. This may be more interesting for someone is studying the electrical field, but we can get into this if there are some specific questions about this. The generator is mainly composed by a rotor and a stator. The stator, as the name is a static piece of the generator, and the rotor is the ones receiving the mechanical energy. Okay, we have topologies in which the rotor is not it is not does not have any winding. We have several topologies in which the stator is connected to the grid and the rotor is used to control the energy. We have topologies in which we have the converter at full power rating of the generator. We have this as a partial rated converter, and we have other several topologies. Vestas has a long way on developing, installing, and control and servicing a lot of these topologies. That's why it is the leader in the market. About the pathway, remember this is 2018, 2019 TEND, which back then we were talking about these turbines. The first 10 megawatt turbine in the history from Mitsubishi offshore wind, Mitsubishi high energy. What was the meaning of MHI? Heavy industry. Mitsubishi heavy, heavy
Exactly.
industry Vestas offshore wind. Yes, and they have also the record of the largest commercial wind turbine back then. But this may sound familiar because this is a joint venture that are now part of the Vestas, and we can see these. There are some other manufacturers that um, develop some turbines, maybe in paper. Some of them are installed, big ones. And this is other turbines holding high power or a big rotor. Please stop me if I'm too fast or if it's clear. I will just go on. That was part of the investigation. As I said, it's part of a conference, but this is what Vestas is doing right now. We have 24,000 turbines installed globally, which are under a service contract. We have over 10,000 turbines installed worldwide, also in service or in installation, commissioning, or in service. And we have this new platform, the Inventus platform. Remember when I said about turbines, which, diameters around 170 meters and around 6 megawatt expected for 2025 or 2030? Well, we have this today. It was introduced in 2019, and the turbine takes some of the characteristics of the turbines already installed in onshore and some of the characteristics of the turbines installed offshore. You can see these options right now in the Vestas webpage for onshore. See the 2 megawatts options. You see the nomenclature is describing the diameter and the power. And this is about the wind. Maybe Andres can say something about that if there is a specific question about that. We have the 4 megawatt variants and the Inventus line, which is 6 megawatts, and the rotor can be as big as 150 or 162. About the offshore was expected to be around 5 to 10 megawatt for 2025 or 2030, and we have these options ready for the market and already installed. A lot of them already installed. 10 megawatt, 4 megawatt, 9.5 megawatt, and 174 meter, 174 meter diameter. And this is the new announcement of the new platform. It's a 236 meter diameter and 15 megawatt actual power. So this power and diameter and size race is where we are the leaders right now, and you can see the video at the end of the presentation of the Inventus platform and the offshore wind turbine. Okay, as I said, it is part of the sales presentation, so some of the content is present in YouTube. You can see a lot of information in YouTube, but the information is some of the information is restricted, but this is only for educational purpose. Okay. So the information about these inventus, I have already talked about the converter. This is a full-scale converter, which means that the converter is rated to the full power of the generator. We have the medium-speed drivetrain. This is not a high-speed drivetrain. This is more like a hybrid drivetrain. We have a special structural design in the blades. We have a nacelle. We call this box a nacelle that contains all of the components in the wind turbine, and it is designed in a way that it can hold all of the equipment, deal with temperature control, deal with loads control, deal with a lot of multidisciplinary areas. What we are trying always to go to turbines on larger diameters. Well, the main answer would be to work with different characteristics on the wind. Larger diameters can have a swept area, a greater swept area, and with lower wind speeds, it can produce a high level of power. Also, wind turbines have to comply grid code, which is more demanding day by day, trying to compete or to equalize or to balance the grid or the energy transmission system. Also, what I want to say about this is these turbines or the nacelle or the design of the turbine has to include some environmental facts. Okay, we work in this turbine with hydraulic systems, mechanical systems, electrical systems, and what we are trying to cover with this turbine is the lowest impact. These turbines, well, they save CO2 production, well, compared to carbon or to other fuel based generating systems, but also we are trying always to reduce the footprint by not well, containing all the emissions or the spills into the nacelle, and always trying to saving the integrity of the people and all of the equipment inside, right? How we're reaching those diameters and those heights in the turbine? Well, some of the key factors are the large diameter steel towers, which is a special design of a tower in 3 sections with vertical flanges that will help us on reaching those heights with I would say some winning factors like the increasing of the AEP, which is the annual energy production. The wind is more generous on a higher altitude. We need a bigger sweep area, so we have to extend the tower of the wind turbine, and it is always challenging to transport those tower sections, and all of this is taken in the design of these large diameter steel towers. This is the timeline of the Inventus turbine. It is now installed. We have now installed the prototype, and the certificate is now available for the installation in other wind fields in LATAM. Hope you catch something about this. We'll try to get the questions and try to answer them in the best way. Thank you.
Thanks, Alejandro. Thank you. Barbara, do you think that we can have the videos for the Inventus platform and for the B102-36?
Yes, let me open them.
Would like to show you those.
Which
those
one
videos
first? The Inventus?
Yes, please. The Inventus, please.
Okay.
That's the onshore turbine.
Exactly. Mm. So this is the platform that Alejandro was speaking earlier. It's an onshore turbine, which was launched in 2019. Right now, prototype has gone through all the testing and the certificates are available. So those are the turbines that we're currently installing, starting this year in Latin America. Great, thank you. So as mentioned, this is the biggest onshore turbine that we have, and we'll see now the latest platform that was released. Actually, you can see on February 10, which was last week. This is even new for some of us in the company because this was an internal release before the going out for public. But this turbine most likely will start to be installed in more than a year. But this is where the technology is going. Thank you, Barbara. Thank you. Well, save your questions just for a few minutes because we'll have now Sergio Hernandez, who's with us in the conference call. Sergio, it's been with Vestas for a few years already, and I think he has one of the most complex positions in the company because he works with very very high evolving teams and people and a very fast growing company. So Sergio, it's in charge of the uh, PNC department for Vestas all over Latam. And he will talk with us a little bit about the company, where are we now in Latin America, and what's the future for us too. So please, Sergio.
Thank you, Andres. Just a little correction. I'm responsible for LATAM North only. LATAM South, it's managed by another PNC partner, but thank you, Andres. Nice to meet you. Can you see my screen? Can you see me well?
Yes, we
Great.
can see it.
Great. So I want to talk to you about what's working at Vestas. As Andres said, it's a very fast-growing company. It's also a company very focused on people, and also it's a very lean company. You won't let me lie. We are very few people doing a lot of things. So if you know what's a lean company, I think it's the leanest company I've worked ever. So it's a challenge for everyone to be motivated, to be very engaged with the company. So I agree with you, Andres. This is a very challenging position, but I think all my colleagues here in Vestas are very talented, and it's a very challenging company. So what can we do in Vestas? The first thing I want to share with you, all of you here in this conference, is Vestas is the first company to install 100 gigawatts of wind energy in the world. So as my colleague said, we are pioneers in a lot of aspects, but the first one is that we are the first to install 100 gigawatts of wind energy. And telling wind energy, it's green energy. Oh, we have in Vestas some student and graduate programs. I want to do this little commercial also for you to join us, to see all the positions we have open for you. And there is a specific page in internet that it's careers.vestas.com, in which you can apply for any of our positions. And there are some specifics for students. So don't forget to follow us in our social networks and to visit our page. Um, what's the business of Vestas here in Latam North? Well, not only in Latam North. I will start about globally. You can work with us in a factory. Actually, in Latam North, we don't have a factory. We have a partnership with a factory of blades in the north of the country, but it's not Vestas. They manufacture blades for us. You can work also on a site. You can be a service technician or a service supervisor, or also in a construction site, or even you can work in an office. This is very open, so I will go through specifics on the next slides. What is Vestas? We have talked a lot about our products, that we are pioneers, but we are our headquarters are in Denmark. We are a Danish company, and we have different SBUs or sales business units across the world. Here in Latam North, we have our, let's say, headquarters in Mexico City, and we have some other offices in Panama and in Colombia. And also for the rest of LATAM, we have a factory or a production factory in Brazil, also an SBU in Brazil, another office in Chile, and another office in Argentina. That's part of our region. It's a very complex region, so I won't bore you with the structure because it's very complex. And doing some zoom in LATAM North, where are we? We have 3.8 gigawatts of installed capacity under construction on or service. Maybe you don't understand what's the meaning of service, but I will tell you later on the slides. And we have presence on all of these countries. Our biggest country nowadays in LATAM North is Mexico. We have 2,484 megawatts of capacity, installed capacity, and in the rest of Central America, Caribbean, and some countries of South America, we have also some projects already running. That is what we mention as service or under construction. So, for example, we have these projects in Colombia, which is a new project from 2020 and will be under construction this year. It's a very huge project of 524 megawatts. Well, a little less because we have another project there in Colombia. And in almost all Central America, we have presence, except for Belize, in both stages, in service and construction. So this is LATAM North, this is Vestas. But what's our value chain? What do we do in Vestas? And let me start about how the energy sector works for almost all the countries. And let me be very specific. We are the responsibles for the technology. We are the responsibles for doing all these beautiful nacelles and blades and the design and all of this structure. But as the energy market works today, we install we install these turbines, and our clients are responsible for generation. All the power generation, electricity generation, is responsibility of our clients, and then the distribution is mainly responsibility of central entities, like here in Mexico, the CFE. So going back to Vestas and what do we do in our value chain, we have these 5 principal areas: R&D, research and development; project planning and design; procurement and manufacturing; construction and installation; and operation and maintenance. The third principal areas we have in LATAM North are these 3. Because we don't have a manufacturing here, but we have a blades manufacturer in the north, and we have to do this partnership. We don't have a design center; it's in Porto, but we have some positions that are the link between this design center and our central offices. And now here in LATAM North, our activities or principal activities are related to procurement. How I like what Alejandro said, that it's very difficult, and imagine how can you send a blade or a tower to a very remote place in the world. That's the things that the procurement and transport teams need to figure out. And also, with all these plans, we have to construct and install with very strict targets of timelines. And that's the responsibility of this team of construction and installation. And finally, we deliver the keys to our clients they are responsible for generation, but normally or usually with these turbines contracts are some service and maintenance operation, and well, more maintenance than operation, more service contracts for 5, 10, or 15 years. So the teams are distributed on these 3 specific areas. And going back to this slide, we have some service teams here in Mexico, but also construction teams in Mexico. We have this regulatory issue right now that doesn't allow, or doesn't, let's say, give the opportunity to some companies to build new projects. So we're focusing the well, let's say we're focusing the strategy to other countries like Colombia. Colombia, it's a very big market, which we have some opportunities. Dominican Republic, and all of these areas and these teams have a place here. And that's the important thing to speak with you as students, as growing professionals, because you can be part of this, can be part of this change. If you want to be in a company with very diverse teams, we have a lot of nationalities, a lot. We're working a lot to be a very gender balanced company. So I suggest you to follow us on social media, to share our opportunities, and to connect. Let's be connected. I'm not very active in social media, but if you find out, you can write me, and we can share some thoughts, and be in contact to be colleagues someday. I will very happy to that. So the 3 principal social media we have, it's Facebook, LinkedIn, and Twitter. And that's all from my side. Thank you, Andres. Thank you, Alejandro, for the opportunity of sharing this.
Thank you, Sergio.
Thank you.
Okay. I don't know if there's any question or.
Yeah. First of all, thank you for that talk. That was great. I do have a quick question. Here, I'll turn on my camera so you know you're not talking to a random person. Regarding the Inventus platform, right? It gives the ability to manufacture and put on very large wind turbines. Now, my question is, how does that correlate to the operational costs of putting those turbines on? Also, the maintenance of those turbines, since they're much larger and have a lot more strain and pressure. And also, how does it play with the policies of having an offshore wind turbine and having it be close enough to the grid, but not so close that it goes against some regulatory policies that the country might have? So really operational costs is my question.
Alex, do you want to? Okay.
Yeah.
Go.
Well, this is a good question that well takes a lot of maybe we have to gather the whole team to answer that question, because it takes some of the logistics, takes manufacturing, a lot of operational topics, governmental strategies. I would say that Inventus is a flexible platform that can be adjusted to maybe those to the complexity of your question. It takes different kinds of plates. It can be different sizes of towers. The output of the generator can be adjusted. it is a very big question. Maybe we can have this discussion in another session. We can prepare for that question and address that with the teams that is handling this right now in the company. I am sure they have this solved because they are installing it right now.
If it's okay with you, the Vestas team to share or to allow us to have some contact email so we can channel these technical questions to you, that would be nice. I mean, I have some of your emails, but the thing is that if you want them to be shared with the students so they can reach out to you and ask these things. So I let it to you to decide whether it's okay for us to share this information, or you let us know where these questions can be addressed. But by all means, we will have to follow up.
Yeah, because if we were talking about some mechanical issues or stress or about the design of the blades, we can get into that. We can talk about this special design of the tower. As I said, the large diameter steel towers that takes all of a lot of technology, all of 20 years of development, mixing the standard towers in the upper section and the large diameter steel towers in the lower section that can be segmented in three parts, that it is easier to move around the land or in the sea. It can be installed in a modular basis, the generator, the drivetrain, the blades also. So we can have this well, this discussion all day, or a new presentation about this. But I will be glad to take those questions and address.
Thank you.
I have another question. It's regarding the offshore wind farms or the turbines. As soon as you said like the offshore system, I imagined all the implications that it would take to, well, in my state, I've seen the process of the wind farms being built on land, and it's very time consuming and it's a very long process. So in the offshore sector, more things have to be taken care of, like the soil and especially the corrosion in the ocean. Are those turbines specially designed to withtake the adversities at sea?
Yeah, sure. Actually, I took some slides out from the original presentation. One of them managing or addressing this foundation, a special foundation for these offshore turbines, different floating system, different what I don't know the term, but to fix and to install and fix the turbine in a specific location in the sea or in a low level water or high level or whatever. And also I took out one slide that takes some of the peculiarities of these inventos, that and it was about corrosion, it was about humidity in the nacelle or in a specific locations. I would say, ¿cuál es el nombre del armario? Un armario. Well, we have to deal with humidity, relative humidity, temperature, corrosion, and those facts have to be site-specific design or a standard design that can be installed around the globe without a problem. But we have challenges, right, in those topics. because we are installing turbines near the sea, close to the sea, right in the beach. We are installing turbines above 3,000, above 2,000 meters above average sea level. We are installing turbines below 0 degrees, above 40 degrees Celsius. Well, that is a good question. And if you need more information, we can look if there is some public information about that, or take that as a, we can share some comments about that. No problem.
I think what Alejandro is mentioning, it's very important. I mean, when we think about offshore turbines, we imagine like really harsh conditions, but even in onshore turbines, we found those. I mean, like turbines installed, for example, in very humid environment like Brazil or Central America, or high lightning density at the south of Latam, or even north of Mexico, or high altitude, right? That's another one, or high temperature. It's also, so it's all this let's say experience together makes the technology and design to go forward, right? I mean, offshore, it's a really important way of learning things, and also about operating turbines in the sea. It's a very demanding thing, but gathering information from all environmental conditions, even offshore, onshore, makes technology develop in a way that sites can be managed to be built, right? Finally, so it's a really good condition, and it's also an important question to make us, right?
Thank you very much.
Thank you. We have Alberto Ballesteros with a question, please.
Yeah, thank you. First of all, I would like to thank you for the presentation. It was very interesting to get to know a little about Vestas and the wind energy here in Mexico. So my question is regarding the recycling of blades. What is Vestas doing right now with that problem? And I mean, I'm asking this question because my final project as mechanical engineering right now is, well, there's an opportunity for me to focus on achieving something with regarding that topic, and I would like to know if there's this possibility of also working with Vestas about that. So
yeah, well, Alberto, you just mentioned a really interesting topic about the turbines in general, and that's one of in regards blades, right? And we all know that the most likely blades from a wind turbine are made with composite materials, fiberglass, carbon, some resin, and some other materials that most of them will not be able to be recycled, let's say, in the same way, or returned to the original condition. It's an important topic, and moreover for Vestas, which is compromised with environmental, and we have a very strict policy about carbon footprint and so on. So one of our goals is to become a cleaner company by 2030. And one of the main points in this agenda is in regards of blade recycling. So finally, this year, Vestas has taken one step forward in this direction, and we are partnering with some local associations and universities all over Europe to develop what we consider will be a solution for recycling. And this investigation will be, let's say, this project will be developed in the incoming years. The goal finally is to have an answer for this specific problem. By today, we don't have a clear understanding or path where we're moving forward, but of course, one of the main objectives is to reduce first of all, the carbon footprint when it's a matter of blade production, and then what we're doing with our blades once they are decommissioned or they stop functioning. This takes us to the recycling process. So it's ongoing. This is a very important point to be covered. So if you are interested, I would say that maybe you can get with Carlos, and we can share with you some information, as this is something that it's happening today and most likely will be developed in the incoming years.
Okay, sounds great. Thank you.
Mm-hmm.
Señor Mauro, you have another question?
Yes, I got another question for you guys. Once again, thank you for your time. I had a quick question regarding what Sergio was mentioning about how the distribution, like the responsibility on the distribution of the energy is placed more on central entities of the country you're working in, more so than the company itself. Now, does that also mean grid integration? Like, or is that part of the R&D that you provide as Vestas?
I think you can answer that, Alex.
Mm-hmm.
Yeah, but please repeat the question in a few words.
Sure. So if we want to integrate that wind energy into the grid in an efficient way,
it is integrated.
Exactly. So is that on Vestas to figure out how to do it, or is that on the central entities to figure out how to do that?
Well, we have to comply with grid code, and the grid code central entities, they develop the grid code in some cases along with the manufacturers or the technology developers or technology manufacturers, but sometimes they don't. So they establish the grid code in terms of stability or frequency ranges, voltage, reactive, isolating, connection, disconnection, low voltage right through, high voltage right through, and a lot of specific behavior. We have to comply with a specific parameters and behaviors, speeds, and the technology is evolving. Well, the topologies in the converters, in the generators, have changed year by year to match those grid codes. Some technologies have been integrated into the wind farm. We have now some storage added to the energy storage added to the wind farm, to the wind turbines. We have full size converter which deals with the reactive power handling more in a better way than the WFED was doing before. We have reactive capacity banks, and the control is getting more complex day by day to trying to get into those codes. Some of the wind farms will work or try to comply with the grid code that was valid the date the wind farm start working on, and they in Mexico they are not forced to attend or to comply with new grid codes right now, but new projects are or have to in order to connect to the grid.
Perfect. Thank you.
Yeah, it is a complex issue. So the developers of the grid code are trying to push the the renewable energy to behave or to work as the conventional gas or hydroelectric plants. They have a constant input of energy, I would say carbon or whatever fuel that is. And wind is not constant. That's why we are always pushing the AEP, the annual energy production, in order to have the more stable energy from the wind that is changing. We are mixing a lot of technologies in trying to comply with new grid codes.
Great.
It
I
is
also have-
it is part of R&D. It is part of R&D, taking the new designs to comply with the grid code, and it is
Perfect.
part of service and construction to get those parts into the turbine in order to comply.
Okay. And another quick question. I don't know if we're running out of time. I could be here all day asking, but another quick question.
The last question, Mauro.
Okay, thank you.
Okay.
Is there any policy compliance that you guys have to abide by on the size of these turbines? Again, the new platform is allowing you to do very large wind turbines with large sweeps, right? But is there any policies that might hinder you from being able to place a large wind turbine somewhere? Very much so like in a city where there is restrictions to building skyscrapers and how tall they can be.
Yeah, well, in the instant or in the time that the wind turbine is getting larger, you are now talking not about grid codes, not about the energy that you can take out of that plant, because we in the wind well, in the energy sector, you have many other generators or plants from gas or whatever fuel that they are larger than a wind turbine. Okay, but they are fixed into a specific place, and there is like a facility. The wind turbine is placed or installed in some places that are or have to, how can I say this? We have turbines in the mountain or near the sea or in a places that we have to comply with local policies that may apply to a building and then may apply to the wind turbine in terms of the size. So it is more complex, and it goes beyond what we are doing with the converter or the generator or the composites. The size matters.
Thank you, Dr. Oyoki, for your patience with the questions. I can see
No
that
problem.
there might be more on the way in terms of technical inquiries. I'll follow up with them and you, and we can see if we can set up some other forum for us to keep bugging you. Just as the last thing, because the time has run out, and in fact, Sergio had to leave because he had another meeting. I just would like to very quickly ask you about, as you both, or ask Andres about the installation of the wind farm in Querétaro, because I keep telling my students about it, but most of the times they don't believe me. So can you tell us about it, please?
No, in fact, there's one site under construction now in Querétaro. The project is called San Pedro, and this project, let's say it's composed by 15 turbines, 15, B120, which is basically the 2 megawatt platform. This will be 80 meters tall turbines, which I would say it's one of the, in my opinion, was one of the more reliable turbines in the market right now. And I don't know, let me go back, but I think as per the last update that we received at the beginning of February, it should be already erected 5 turbines, just waiting for the nacelle and rotor, and the project should be completed by week 33, 2020, which is I don't know, maybe June, something like that, June 2021. So it's in around, I don't know, 4 months. So it is a project, it's ongoing, and it's one of the first project that Vestas is building now in Querétaro.
Thank you. So one of the purposes of you guys talking to us today and create this first approach is to try to get some sort of partnership that we will work through, that will take some time between Vestas and Arkansas State University. So we can have some potentially some visits there, bring the students. As I know, this is in Huimilpan, which is not far from the university anyways. So I have gotten some students asking me already if they can come. And I said, well, Vestas is providing the equipment, but they need to talk to the owner of the project, right?
Exactly.
Those handling the installation and basically who bought these turbines. So
exactly.
We will keep waiting for that and see if there is a possibility for us. But other than that, thank you very much, guys, for your time, your disposition to talk to us today. I don't know, Barbara, if you want to give some closure to the meeting, and we let these fine gentlemen go on their way.
Well, yeah, thank you very much. It was very interesting. I see that there were many students engaged in it, so they know about what you do, the company in general. So that is very good, I believe. And just to close, well, if there's no other question, I'm gonna share my screen and I'm gonna just show you our certificates of participation that we prepared for you. We'll make them deliver to you some. So this is for you, Andres. We have also for Sergio that had to leave, and at the end for Dr. Oyoki. Thank you very much. We really appreciate your intervention in this third edition of our STEM Week, and on behalf of the STEM Week committee, we just thank your participation again.
Thank you. Thank you so much.
Thank you all.
Sorry, I need to stop sharing this. Yeah, okay. So thank you very much. And we'll definitely keep in touch.
Thank you all. It was such a pleasure to be with you today.
We learned a lot.
We may have a Vestas week, no?
Then you invite us. When you have the Vestas week.